There we go.
So that was the theory, that one button will make us live.
Yeah, so
Are we live?
should be live.
Are we simulations? Emulations? What's the difference between simulation and emulation?
This is actually AI rendering us right now. Real time.
Learned.
Did you hear about the there's like TV shows on Twitch that are AI generated right now?
I've been watching people who generate AI stuff to show what they can do. And they show you the little tricks like look around the eyes and the mouth where things get indistinct and stuff. But yeah, there's some cool stuff. The world's changing. It changed. We just don't know it yet. So, cool.
Right.
Now, in my day, flesh tone, we only had 16 colors. So, back in my day, we were lucky to get 8 bits. We didn't need no stinking ECC bits.
Yeah, it looks like we are live and good.
Okay.
We haven't started recording yet. We're just live.
Oh, I didn't know that. I was just giving you all a lot of fun to.
No. So no, we're just live on on not Twitch.
YouTube.
We used to be on Twitch.
I
We're on
YouTube.
YouTube now.
So they truly do get the backstory of this stuff on YouTube
Yeah.
if they tune in.
Yep.
Yeah, I wonder if I can do.
And
Today's
then,
secret code is 3921.
at the end of the episode, just hang on for a moment because this the platform has to upload your audio. It only takes a few seconds, but
Got it.
just we had someone once who was just we finished the podcast and they were like later and they just
More.
left. Right.
All right. So do I have to initiate the record? Probably not, right?
No,
Nope.
it's on my end. I'm actually.
It'll,
I'm not. I'm futzing around with the stream thing because I'm putting your name in our overlay.
So just so you know, in the show notes, there's a little intro that Parker and I will do, and then
Okay.
I will read your bio, and then we'll just go in from there. So that's just how we start. The
Okay.
episodes.
Yeah, I thought you were letting me start by talking about simulations and emulations. All right, these guys go with the flow. Okay.
I actually like that question. It's got me a little bit stumped. Just if there is any kind of difference between the two.
Oh, there is. I'd have to think carefully about how to use the phrase carefully these days. So I told the guy that wrote BASIC for the 128, I said, yeah, I stored all my memories in 16-bit. Now I look in the locations, I'm lucky to get 5 bits back. And he gets real quiet and he goes, well, it's a good thing you don't have ECC turned on or you'd get nothing out of yourself. And I'm like, he's too quick, even at this age. Good thing I don't have ECC turned on.
Is it really? Are we actually on? Okay, yeah, no. 381. For some reason, that seemed wrong.
What, 381 episodes?
No, just the. I didn't think we were right at that point yet.
Oh.
I guess we
It
are.
sneaks up on you.
It does.
As life oftentimes does.
Well,
Okay, I think we should just go ahead and just jump into this and start it before we start making more podcast content that we can't record.
Can't use? Yes.
Yeah. And so on. Oh, it's going to do the countdown thing. We're still getting used to this new piece of software. Like, we just switched this a couple episodes ago. But it's got some cool stuff like,
oh,
on.
Parker's so proud of this.
It's got echo cancellation.
It has a sound for it. Exactly.
So silly. Our old software didn't have that, and I was actually talking with the marketing people, Steven, and they want me to put like the intro and outro music in there.
Oh, okay.
Yeah.
Can you train an AI to know when to do a rim shot?
That's a good question. It would just look for when all the channels are peaking from people laughing, and then it just does it.
Yeah. That's deep. That's using metadata.
Yeah, that sounds more like brute forcing. It actually has to listen and
Right.
interpret.
That's the envelope, not
what
the
if-
content.
Well, what if the AI develops a humor that no one else actually has?
What'd be scary is it finds another AI that gets it.
Yeah. It starts making its own AI to listen to the podcast, so
That happened. They were using one AI to gauge the performance of another, and they started talking to themselves using a language that they were not told about. They invented the language. These are two Google AIs a couple of years back.
It's way too close to Skynet.
So it was literally telling it how to pass the test that it was there to perform on the AI.
is allowing it to cheat.
Yeah,
That's
in
good.
code.
The robot overlords are just
They've already chosen
plotting at this
sides.
point.
Yeah, they already changed the sides.
I, for one, welcome our overlords.
Okay, I'm gonna start it.
Okay.
Welcome to the Macrofab Engineering Podcast, a weekly show about all things engineering, DIY projects, manufacturing, industry news, and this week we are joined by Bill Hurd. We're your hosts, electrical engineers, Parker Dolman.
And Stephen Craig.
This is episode 381.
Bill Hurd is one of the early engineers of home computers, having led the hardware design for the Commodore C128 and Plus/4 series of computers in the mid-1980s. Mr. Hurd continued to design high-speed vision systems through the 1990s and now is involved in the online electronics community. He co-hosts a weekly webcast, which can be seen at Coriolis-effect.com.
Thank you, Bill,
Cool.
for coming on our podcast.
Oh, well, thank you for having me.
So before we get started with everything, there's a lot of podcasts and a lot of webinars that you've done in the past, all your Commodore history and that kind of stuff. But instead of reiterating that on this episode of the podcast, you have a new book that you can that has all your war stories, so to
All
speak,
the
in
stories in it, yes. Well, first, you can't actually get me to stop telling war stories. That is a misnomer. But I'll try and slow them down for you a bit. But
I tried.
I've got the book here. Yeah. So yeah, I got to plug the book. I have a co-author, so I owe it to her. Margaret Morabito from the old Run magazine helped me. She co-authored this, and we got a book called Back into the Storm, a story of the design engineer story of Commodore computers in the 1980s. So it's not a great read. It's kind of a fun read, but it's every memory I had shoved into a book. So I've heard it called just a whimsical chain of ideas type. What's that word? That flow of reason or whatever. I forget the term, but that was how it's been described.
Well,
So,
okay,
yeah.
so before we move on, how about you tell what's one of your favorite stories from the book?
Well, that's funny. I like to turn the question around on you and say, if you had read the book, what was one of your favorite ones? Or if you had a computer, what was your favorite computer? And I'll tell you a story about it. So, no, the book starts out, I'm a high school dropout, but I loved electronics. And so I taught myself electronics as much as I could. I trained all the kids in my small town in Indiana. If they found a TV chassis, to drag it down the alley to me, and the kids got good. They even know to put it in the zenith pile for me and stuff like that. And these were the days when swapping tubes actually would fix things. So having a tube collection sorted by vendor in your backyard was actually advantageous. So I did take a class in TV repair so that I got some formal education. And then I got a job at Pennsylvania Scale Company as a technician, and I worked my way up to engineer. And I was able to do that because I had read the data books, the national data books that you could buy from Radio Shack. I'd read them cover to cover. And that's literally how I got my foot in the door and became an associate engineer, then an engineer. And, so it was that passion to teach yourself back before there was an internet where you could learn. You could only learn it from books or from somebody else back then. There were no TV shows for this kind of thing, no webcasts. So, so I got to Commodore. And they must have recognized that, when I showed up the day they went to hire me, I didn't do well. I screwed up the interview more than once. But at one point they caught me. I was muttering these opcodes under my breath as the guys talking the machine code. And they realized I understood the opcodes inside the thing. And they're like, okay, come on down. Meanwhile, long hair, in jeans, that type thing. So, yeah. So I'd say it's just, the intro of the book where it tries to take you back to the 80s, time before cell phones and we had just gotten a thing called a fax machine back then. So, yeah, so cool.
So where can people get the book at then? Is it the normal people like Amazon or?
Yes, it's available through Amazon. It's and it's available as Kindle. And the bad news is if you buy the hardbound book, you don't get the color pictures. It's actually backwards. But so I recommend buying both.
Amazing.
Well, cool. So our first topic today, I guess we can talk about the couple topics we're going to discuss today. So it's going to be the Vintage Computer Festival.
Yes.
It's going to be your show. That was Coriolis Effect.
Yeah.
Okay. And then DFM and assembly process, kind of just over your career, so to speak.
Yeah. To talk, to try and link to new stuff so these young kids these days can relate, That's back when your DRAM only had like 16 leads on it, the 8-bit days. So, but no, VCF East, which we've already had, we had it April 23rd, something like that. We had an amazing turnout. We broke all the VCF records. We, coming back from the pandemic helped.
Oh, so VCF is the Vintage Computer Festival.
I'm sorry. Yes, thank you. The Vintage Computer Federation, which holds VCF events, which I call Vintage Computer Festivals. And so we had the festival last month on the East Coast in Wall, New Jersey. And I hosted a roundtable of webcasters. I don't personally care for the term YouTuber. But some people are YouTubers, but not me, right? But we had Fran Blanche, Jerry Ellsworth, we had Usagi Electric. Who else am I forgetting there? The 8-bit guy, Adrian Black. We had all these very cool people all on stage at the same time to talk about making webcasts and and how they respond to the people that watch them and whatnot. So we just had a great event. We had the consignment was just crazy. It was backed up out the door by 8 in the morning.
Just how many people bring stuff to show off?
To sell. So
to sell.
Is that's where people go the first day, early in the morning, is to get the good stuff out of consignment. There's people walking out with Amiga 600s and stuff, just and all smiling, right? And nobody complaining about the length of time to stand, because it was in a small room this year and they would only let a couple people in at a time. So they're working on that part of it so that we do it, but it was due to growth. So what a great reason to have a slight hitch in a VCF. So that was East. I'm going to be at VCF Southwest in Dallas, Fort Worth, June 23rd through the 25th. We're redoing the round table, and for there I've got Mark Verdell, Curious Mark, you may know him as, off the internet, and we got a bunch of other people for that round table. And again, people like 8-Bit Guy will be there and whatnot. So it's a really good show. That's 23rd to 25th in Dallas, Fort Worth. And then August 4th and 5th in VCF West, which is in Sunnyvale, Palo Alto, that area. We're just now getting all the people together for that, but we've got Dave Plummer from Microsoft will be one of the, and we're doing the panel again. And there I've got Dave Plummer joining us. So it's a full summer for VCF if you're into the vintage kind of thing. Are you guys into vintage?
So for me, I actually got my start in electronics modifying old Atari 2600s.
Okay.
Not really the computer side of vintage. I've had to scrounge around to find a floppy drive to make this new old camera I just picked up work.
Right.
I finally found one. Had to go to a Goodwill to pick one up.
Right.
But yeah, not really old in the old computers. Because I didn't really get into computering until about the it'd be the P2 era, Pentium 2 era.
Okay. The bland era of IBM PCs and their clones. Yeah. It's so I don't use vintage computers myself. I saw them work 40 years ago. I don't turn them on. I don't play with them. I occasionally will stroke one or something. But I use the FPGA Mister and emulate some of the computers I've worked on. And what's really cool, we had a noise problem in the C128 called jail bars. And back then, we didn't know as much as we know about grounding and stuff these days. We literally grounded our chips and powered them incorrectly. We did the opposite corners, which has the most inductance compared to 2 pins side by side, let alone four ground pins. So we have these non-moving noise artifacts, and they're called jail bars. Well, on the Mr. FPGA, there's actually a setting you can turn on the jail bars. So it'll emulate the noise of a C128.
That's really interesting because you see that a lot too in emulators for older video game consoles and stuff, where you can add in the CRT lines and that kind of stuff.
Yeah.
And I always thought that's interesting because I'm not nostalgia for that. When you see media that it matches, but for actually playing the game, I'm no, that's something I didn't want to do. That was the whole thing with me doing the Atari video mods for the 2600 was to get rid of that noise, and so you could actually have a clean picture on your screen.
Oh, is that the mods you were doing? Some low pass builders or something?
Yeah, it was picking up. It was basically bypassing the whole radio frequency circuitry that's built into it.
Yeah, you took the modulator out of the equation.
Yeah.
Yeah. Well, that's cool. Yeah, we used to get drunk and play 2600 Invisible Tanks. You know, it was
Yeah.
the 70s. What can I say? It was. So even then, I was known as kind of the computer guy because I had a 2600, you know, in 75, something like that. Back when we thought they were just electrons and didn't know about electron fields, so EM fields as much, you know.
Back in the good old days.
Back in the good old days where, yeah, electrons went one way, holes went another, you know, and that's just how current flowed.
So, on this topic, Chris Kraft from our chat has a good question
Hey,
or a good
Chris,
statement.
how you doing?
Or a good statement. Chris says, I never understood how retro fans are so much against FPGAs, seeing Commodore would frequently spin up custom chips when needed.
Right. I have no problem with emulation or anything like that. Yeah. God, I remember the very first FPGAs. You had to hand route them. The very first Xilinx. You had 64 elements and you had to sit there and hand route it. I swear it was just like making a PC board. It wasn't easier. It was just different. Yeah.
Was that done through their IDE?
Yeah. And
So you had to do the best fit part yourself.
Yes. And it used the CGA monitor. So you had like 4 colors. I still remember that yellow and the green and some wonky red or something. I forget what the 4th color is. So, no. Working at Commodore was like working above a dragon, right? A dragon's den. Because there was a chip fab in the ground floor. This is when I got to MOS in Norristown, otherwise known as King of Prussia. And you know there's a chip fab down there. You just know it. You smell it. The building vibrates. There's trucks pulling up full of liquid nitrogen, you know? So, and then the engineers are walking around dressed as wizards with little pointy hats and unicorns and stuff. And you could make any computer you wanted because we had wizards. We had real chip designers. So I'm kind of known for going Apple, they just used our chips. Well, that's not quite true, but that's the way I looked at it, being a good old MOS employee, Commodore employee. So that was definitely our edge. We, the philosophy that we designed for the masses came from a consumer point of view. I've designed instrumentation. I'll tell you, Commodore computers are, I want to say they're like toys. They're designed as a consumer product. They, that no more reliability than you would design into a toy. So it's amazing they even work to this day. I catch grief. It's like, well, if you put a bigger heat sink on there, it would have lasted longer. How long did it last? Only 39 years. If it had a heat problem, it'd have broken in 7 months.
Yeah.
So yeah. But it's amazing. The internet is keeping the vintage movement alive. The number of people that know the name Commodore seems to be growing to me. Or let's say it's easier to find each other in these days of Discord servers and whatnot.
Or just go to Vintage Computer Festival.
Go to a VCF. Well said. I couldn't have said that better. VCFED.org. We should kind of put that out there. It's you got to know how to find it on the internet. And they let's see, VCFED.org. Echo Delta. There you go.
I'll make sure that goes in our show notes.
Oh, cool. Yeah, I'm kind of a wrangler for them. I like them to have good shows, so I go around and bothering people going, why don't you come speak at VCF?
Yeah, for vintage computering, really the only thing I deal with on that regard is, because I don't really do the Atari stuff anymore, but it's actually more like pinball, which is a computer inside of there.
Yeah, no.
Yeah.
We went out last VCF East. We got Jerry Ellsworth to come out. And Fran Blanche had suggested that we go for dinner right next to this pinball arcade in Asbury Park, New Jersey. and they were there till midnight playing pinball together. And it's like Jerry Ellsworth can lift a pinball table, and kick it about 7 inches, 8 inches without it tilting. And she's this tiny little thing, and so we're sitting there trying to figure out the physics of Jerry Ellsworth playing pinball. Where the kinetic energy came from and stuff, right? And she's doing so. She lifts a foot and then kicks it back, and at the same time, and it's a true technique.
There is so how that sensor works. It's a plumb bob sensor.
Right.
Yeah. So if you can move the machine in just the right movement, you can make that sensor not move, but you can influence the ball.
Right.
Yeah.
She slides it more than tilts it.
Yeah.
Is kind of what's going on. And she can slide it, and those things aren't light. So yeah. Oh, we had Usagi Electric had driven from Texas. He'll be at VCF Southwest in Dallas Fort Worth. I recommend Google for his channel, but he's been restoring old computers where you don't know if he's going to get them to work, and then he gets them to work, and it's really cool. That's pulled me in a little bit, because I'm like, yes, it's broken, old stuff breaks. What's the big deal? But to actually see people taking the time to fix it's pretty cool. So speaking of old stuff, somebody out there has a picture of me licking a Cray 1 in a parking lot, a Cray 1 computer. It's like that was the holy grail back in my day, And now your PC is faster than a Cray was.
Why was it in a parking lot?
A guy was bringing it to VCF, and they're like, "You want to see my Cray?" So I'm telling you, those VCFs are cool if you've never seen a Cray computer. Or imagine loading it up to take it for a drive, right? I'm taking the Cray out, honey.
Full box truck full.
Why is it wet on this one side? Was Bill Hurd here? It's.
All right, let's move on to the Coriolis effect, which is the webcast that you do with Ben Jordan.
Ben Jordan, yes. So Coriolis-effect.com. The name comes from the fact Ben's from Australia. I knew Ben through Altium being an Australian company, and we get together not every week these days, but about every other week we get together. We have guests on. We talk retro. We talk tubes. We talk electronics. And then, especially with Ben's background, we talk about design for manufacturing, PCB fabrication, the actual PCBs themselves, in addition to assembly. So it's a way to geek out, kind of. And we do have a Discord server that goes with that. If you go to the Coriolis-effect.com, you'll see a link to our Discord server. So hope to see you there.
Yeah, I'm actually going to join it after this.
Join it now. Join it now.
Well, then I have to Alt-Tab and mess up the webcast.
Oh yeah, we all just freeze and.
Yeah, basically that's what would happen.
So what are some of the topics that you guys get into?
Well, design for manufacturing. Johan Grip is one of our contributors, and he has created an all-new C128 PC board. From reverse engineering it. So there's that project on there.
You didn't have the files on your computer still?
You think there were files?
Joke.
There probably were SiCard
Manila
files.
folder files.
So when we did
Transfers.
this computer, I can't open this one. This used to be called the 264. It became called the Plus4. This is one of the first ones I worked at Commodore, and it's hand taped.
Okay, so you hand taped the boards?
Between the Plus4 and the 128, we adopted a SiCard system, plugged it into a VAX, and so the C128 was Commodore's first CAD-based PCB. But you still had to type in the net lists yourself, and I mean, it was ugly.
Yeah. So on the tape, was it where you could make a template, or is it each board had to be hand taped themselves, like the manufacturing of the boards?
No, you laid it out at 2-to-1, and then and got it all correct. And you know, I have stories where I'm leaning over it and I stand up and there's tapes, there's traces on my arm, right? And the PCB guy looking at me like this, you know. But no, you used to go and get it laser plotted, and that costs money. That costs like $5,000 in the 80s to get a laser plot, where they would take that film and digitize it into a Gerber. And you know, that was the days when you had to be real careful about your drills. You had to have an aperture on your laser plotter of the right drill size, so it has to be common. But yet the assembly fab house had to have the same drill in stock. None of this variable drill sizes like we got today, where you just whatever hole size you want. So it was different. And if you had a photo plotter, you could print money. You could make $60,000 a year with a photo plotter if you could keep it working.
I'm curious, how long would a board like that take to cut tape and lay out by hand?
Month to two. Most boards I've seen weren't less than 2 months by the time you get through all the steps. And how much changes? You know, there's no push and shove, right? It's you want to change. It's a change. You rip out traces, plop a dip package in or something. And,
Now the term "rip up" makes way more sense.
yeah. Oh, you do. You pull it up, and where it crosses other traces, it'll pull them up. You know, it's like, oh. But yeah.
The good old days.
Yeah. So, you know, I'm completely enamored by the ability to send a PCBWay or JLC PCB and get a board. I get boards here in 6 days, 5 working days or 6 days, you know. You can't beat what used to be so expensive is now a few dollars depending on where you go. Mm-hmm. So it just, you know, back in my day, we were trying to make our own PC boards, and you know, I did all that with the ferric chloride and everything, and even milling machines and stuff. And now it's just like, why would I mill if I can just have it back next Monday? You know?
Yeah, that's I did the first couple of boards I ever did was, you know, dipping and etching, and I was just like, screw this. This is not worth the time to do this.
No.
The
Right.
first board I did, I laid out in MS Paint, and I ironed it onto copper and did the ferric chloride, and it ended up working, but I was like, there's got to be a better way to do this.
Well, I remember flipping my board over so that the Sharpie side was down. You know, I had drawn on mine with a Sharpie. Well, the agitation, all it did was wipe it off. So I agitated it nicely for 30 minutes and made a blank PC board, you know, just no copper at all.
edged
on
it
it.
off.
Yeah, everything rubbed off. So,
Yeah, nowadays we even use like PCB boards to make front panels for products.
oh, yeah. I can show you one. They make great front panels because you can print whatever you want. Yeah, I don't want to get out of camera shot here too much, but I do that exact same thing. I make them, and you can get aluminum sided PC boards.
That's really funny because Steven just did that for a product.
Yeah.
And
Oh,
it
nice
looks,
professional job.
It looks fantastic.
Yeah.
I was shocked at how cheap it is, and I thought they were going to be prototype quality, which is what I originally ordered them for. And then they came in, I was like, I could sell this. It looks good.
Yeah. Oh, yes, absolutely. It's sellable quality. Here's. Yeah,
I wish our listeners
what
could
one would
see
look
all
like.
this.
It's and this is an aluminized one, so it acts as a shield and everything, and then you print your logos and whatever size holes or slots, you know, in your front panel.
For those who can't hear, it looks like a little faceplate that goes on an extruded aluminum enclosure.
Yes, little Hammond enclosure. Yeah.
Oh, great. Yeah, it looks fantastic.
So the way I made this one fit so well, just to walk through the process a little bit, you get these little Hammond enclosures. I go online to Hammond to pick them out and then go to DigiKey to really pick them out based on price and availability. Then you go back to Hammond and you get the Gerber, or you get the DXF file outline of what the PC board should be, blast it into your CAD, and it fits perfectly. So I've got this card that fits in here. It slides back up in. I can't do math that well if I'm not using tools, you know. If I really blow it as a mechanical engineer, even though it's just addition and subtraction. But the housing people make it so easy for you to make a product that fits their housing. It's great. So how did surface? So I'm from the days of through-hole, as we talked about. And back then, China was closed, and we made all our high quantity stuff in Japan. You know, Japanese transistor radios was a thing, right? They could manufacture something way cheaper than we could, and that was Commodore's fame, was producing there instead of in California, where we could make a computer cost $200. And I lost my train of thought there. We were making cheap. What was I talking? Oh, so the through-hole, right? So typically, when I first got to Commodore, they would send the design over to Japan and they would relay it out. And they're relaying it out for a Panasert auto insertion machine, the way it hits the board and needs clearance and whatnot. So I figured that's pretty stupid. And why don't we bring some Japanese engineers to the English office and work together to make the board once? And so the 128 was the first board I knew of that was laid out for the Japanese Panasonic Panasert and the American, not Genrad.
And these are the surface mount, not surface mount, these are the through-hole inserter machines.
Right. So we made a board that could be inserted in the Far East or inserted in Pennsylvania. You know, so it was kind of, ooh, you know, look at the two countries to getting together. But we put some time into that because, you know, when you mess around with the quantities we did, a million's nothing, right? If it's like playing with the fire hose. If something goes wrong, everything gets wet, right? It's just so much pressure in a line that size. So if you do have a design mistake, that bell-shaped curve's going to find you and punish you. You know, if you're outside of the distribution of what works. So so that's where I tell people I got my bachelor's at Pennsylvania Scale Company, where I learned instrumentation design, but I got my master's at Commodore, where I learned high quantity, you know, consumer design. And I had chip guys. The chip guys taught me how to look into their chip, and I taught them how to look out to the system. Because chip guys sometimes don't know what's outside the package, right? And we had a chip that in the 128 called the 8563, the 80 column chip. Guy couldn't visualize how it was to be used in a system. And I missed that fact. And so when we went to go use things that are normal, they weren't there. Meanwhile, we had other engineers who I'd worked with closely, a guy named Dave DiOrio who worked on the VIC chip, the later VIC chips. He knew what I needed from him. So that line between hardware and chip guy, they got all mixed up, you know, because we were best friends. We drank together and we worked 18-hour days together, you know. So it was great being able to go tell a chip guy what you need. They're magicians, they're wizards. Right.
So is that like the signals coming, like what you would need to sync up with other components and that kind of stuff?
Which part?
What telling a chip person what you would need?
Oh yeah, he had to understand not signals, buses, flows, back pressure. You know, the system only. So I refer to a computer system as like take a pizza pan or a cookie sheet and put water on it and balance it. That's what computer design is like. Everything's got to be balanced, or again, stuff gets wet. So you know, getting them to understand too fast, is bad too sometimes. So it's and then the whole idea of static and stuff was kind of new in the 80s. We, what a keyboard, what could damage something through a keyboard, that kind of thing. So yeah, we were making the stuff up as we went along. Here, I'll tell you a story, as a matter of fact. Then, when we did this one, the 116, which was the little cousin of the 264, I had noticed when you got the computer near the monitor, little black spots would appear. And I'm like,
I'm hoping black spots on the monitor and not like on the keyboard itself.
Right, little black spots would appear on the monitor. And the bottom line is that the chip designer guy that had designed let me back up. This is the Raspberry Pi of the 1980s. Right, it cost $49. This would have sold millions, right? if we had followed through and made it. So again, I forgot where I was at. I keep getting back into the path.
CRT influencing the graphics of the Commodore 116.
Right. So I take it, I put it right up against the TV, and it crashes. Well, it turns out that they had used the data lines actually were on the connector going to the keyboard. That's how they were reading the keyboard, was the data lines of a processor. We would never have passed FCC. Data lines hate going down these wires and into all the little stuff out here. And it turns out it showed up in the joystick also, because the button on the joystick was was one of the data lines. So my boss, I laughed when I saw the mistake because it was just so hilarious. And my boss was not amused. He's like, "Fix it or you're fired." I'm like, "Okay, I can fix it." He walks in 2 hours later, and I'm sitting there playing Wizard of War, right, on a joystick. And I thought I told you to fix it. I just point. I grin and point. And I keep playing this game, and he's, "I told you to." Finally, I show him I had a 20-foot cord put on the joystick. I had taken the back of the monitor off and wrapped the cord around the monitor where all that scary wiring is. So it goes behind the monitor, around it, and comes back out and plugs into the Commodore. And I'm playing on it to prove I had fixed the problem. But it's like, so my point there being, we were making this stuff up as we went along, so we made a lot of mistakes, right?
So what was the fix?
The fix was I had to put in a latch-driven buffer.
Okay.
This to make it not a data line, but also I had to make the outputs be able to short together, because a keyboard, if you push multiple keys, you're shorting outputs together. So you don't want TTL, right? If you have a gate output and a gate output and the key closes between them, you just smoke it. So turns out that Commodore made the 8529 single port latch I/O chip. I went down, got it from production, and we had it working within, like I said, 2 hours later. So it was, so yeah, we were proud of our screw ups. It meant we were moving fast. I actually required my guys to make mistakes. If they were not making any mistakes at all, it meant they had too much time on their hands. Right? I needed them to make about 5% mistakes. Then I knew we were going to succeed.
So you mentioned like when you were doing all this design, it was all through hole. But since then, we use a lot of surface mount technology now. So what did you have to change as a designer just to...
I had to make room on my bench for a hot air knife. So hot air soldering gun. I mean, it's literally part of, you see bench is, that's a working bench, and it's constrained for space, and as you pointed out, the wood is arcing under all the test equipment. But that was the main thing is, well, you're not desoldering with a soldering gun, but you need finesse, right? Especially on SMT. So just getting good, there's a microscope back there, there's an air microscope over on the other side. Learning to work under a microscope with hot air was just a requirement. So I actually have a video on Hackaday. One of the things we haven't talked about is I created videos for Hackaday. I still do, but not very often. But I did one on all the different ways you can desolder SMT. So I show an infrared desoldering tool. I show multiple hot airs. I showed the tweezers. I did all that. So Google Hackaday and SMT desolder. It's a good read. And then I had another one about how to do your own assemblies. And that's where I go into what kind of oven I use and what kind of flux and these, for example. I mean, people, with pace in their own basement. So, learning to do that and do that well. I do use, I forgot the name of my oven software, not Nucleo. Yeah, it'll come to me in a second. When you get old, the memory becomes read once, wait 10 minutes for it to become available again. So we call that herd memory.
Herd memory.
I'm curious. Commodore days, all through-hole. You have a lot of through-hole experience. When SMT components started becoming available for designers, what was the feeling about that? Were designers like, oh, I don't want to touch that. I want my classic through-hole parts. Or was there a more of an air of, oh, this is cool new technology, I want to get involved in?
I think it depended where you worked, to be honest. We were doing some surface mount at Commodore in 85 because the LCD machine was just coming out, or was supposed to come out. But I personally, I found every excuse not to go to surface mount for about 6-7 years there, and then made the leap. And again, it's like, well, I get the. So we didn't have cheap tools back then either. A desoldering station from Pace would cost you thousands at a time when my salary was $40,000. So having access to eBay and hot air soldering stations and stuff has made it all possible.
It's funny that you mentioned not wanting to make the jump. I actually found this similar in with pinball, where honestly, the designers, we want to use it, but it's the users, the end users, they feel like they can't repair it as easily. Which, in my mind, honestly, surface mount's way easier to repair without damaging the board if you have a hot air gun. Because I've seen way too many people, looks like someone took a screwdriver to that through-hole part.
Right. So I started in production as a production technician at Pennsylvania Scale Company. And one day I've got the big screwdriver, and I'm leaning into it, and you hear a creaky noise coming out of the board because I didn't desolder everything perfectly. And the head of production is walking by, and he goes, "Stop. Everybody come here." The entire production people, show them what you were doing with the screwdriver. And I never pried out another chip again. So So I learned soldering, in production. I learned what broke in production. I learned what tests well or easily in production, what doesn't. I learned stupid stuff like the heatsink grease would get washed away if we washed the boards before one of the steps. I mean, just dumb stuff, right? Again, we're making it up. It's the 70s and 80s. But yeah, a lot of cool stuff. I remember our first dishwasher, all it did was make, we went to washing the boards with water. We had hard water. Nobody put in a water softener. So all we're doing is I think we were using Calgon for a while to try and clean the boards, the stain, the glass stain remover for your dishwasher.
I guess that would work as a saponifier.
Yeah, a little bit.
A little bit.
The real fix was getting the right water, DI water.
My next thing I want to talk about is, because I've taken a lot of old stuff apart, and sometimes you notice green wire fixes, and this is the wire's not green, but
Right.
But these are like fixes, and a lot of times they're in production, like units. Whereas a lot of stuff that we build at Macrofab typically doesn't. Like green wire fixes and our stuff is very rare because usually it ends up being cheaper to just respin the board if you catch it before it. Like, I guess if you built like 1,000 plus or something, you might go back and rewire those. But if you can catch it early enough, you usually just spin the boards before assembly.
Right.
But I know like the C128 has this really nice red wire on it.
Yeah, red, sometimes white. Yeah. So you mentioned the fixing of it. In the old days, and I keep starting sentences that way, we didn't even put solder mask on the board because it would it would increase the cost of the board and add days to the production. So if you look at like old green wire boards and stuff, some of them are so, things were so expensive, there's not even solder mask on the boards if you look at them, because that's just the day. But in the 128, that's this critter. This is a Commodore thing. These make great door stops. Okay, you shove that sucker under a barn door or something, and it's going to do strong wind, not a problem. All right, so that's the size of the thing. Now,
great stocking stuffer.
Recognize the size. I'm sorry, what?
Is that a great stocking stuffer?
Yeah,
Commodore door stop.
And that looks huge, right? But the reality is, 2 of those fit in a panel, almost exactly with just the right around. If I made this smaller, we could still only get 2 per panel, PCB panel, the big, I forget the size that they were back then. But it's still the common size today. So this was what we had to work with. Again, this was done using old tools. It's all through a 2-layer board. There's no impedance control. The impedance of these traces jump from 120 ohms to 10, right? But there is this red wire here that goes around from this processor to the DRAM. What it is the Commodore 128 has 2 microprocessors in it. It has a 6502 derivative, and it's got a Z80 derivative. When we did the last rev of the board, 20% of the Z80 ones wouldn't boot when they booted to the Z80. And we traced it to crosstalk in just the way a 2-layer board gets laid out. There's crosstalk in this part, which we call the data river. Each of these areas had a name. This is DRAMville, this is Bumfrick, this is, each section has a name, CPU land. So there's actually a story, though, behind how I found that crosstalk. We had the problem, and on a Monday, it was the second time that my boss, oh, no, not on Monday, he didn't threaten me. But me and him got in a fight on a Monday, and this is after the CES show. I am worn out, and he's like, rah, 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 and I'm like, fine, then you fix it. Right? Because I haven't had a chance. He goes, fine, I will. I'm like, fine, so will I. And I went home, took a shower and a nap, right? I hadn't slept a full night in months. So a week, that's on Monday. Friday, he comes in, right? And everything's riding on whether these are shippable or not. And he comes in and he says for the second time, fix it or you're fired. I'm like, okay. So I've had a week to rest. Everybody appreciated that I took showers. I'm bringing in food for people and stuff. It's good time. So I got lucky. I go to the lab and I find the source of the crosstalk in Z80 only mode in about an hour. And the way I found it was I would stare at an oscilloscope. I would make the brightness really high and put as much off the screen as I can, and I would stare at it. Then I would look up at a blank wall, and I would see it in reverse. And I could see the glitch, the black on white instead of white on black. So I'm sitting there, I'm like calling over Frank Play, and I'm like, and he's he does it, he stares at the thing and then looks up at the wall, and he's going, I see the glitch, I see it. And nobody believes us, right? So I'm like, yeah, I ran a wire. So now there's two paths between the Z80 and the DRAM, because that's what was wrong. It was one wire had junk on it at the wrong time. And so to prove that it worked, we did 10,000 run, which would be production for somebody else. For us, it was a weekend. We just went down in production and ran 10,000 to test it. And, and they did that to prove if Herd was full of gamuck or not, and it worked out that it did. So people have asked, well, why didn't you cut a new version of the PC board? And I'm like, well, that's the devil I know. I know I can fix that with that wire, but if we move those traces around, maybe the problem moves to some place I can't fix. Our problem was the amount of room we had wasn't enough, but that's life, So yeah, so that wire cost me a penny for the wire and probably 99 cents for the person that installs it, right? So so that's $1 million wire. For every 1,000,000 units we sold, that cost me $1 million.
But they all worked then.
They did. Now looking back, I'm impressed at that young Bill Herd's confidence.
To just go downstairs and run 10,000 of them?
Yeah. What was cool is I didn't run it because they made all the other engineers that were on not so critical projects do the work. So I'm walking up and down the super line at Commodore handing out bottles of beer. And the one engineer's like, why are you walking around with beer and we are here doing your work? And I'm like, what can I say? We're different people.
You found the problem. You didn't have to fix the problem, though.
Right. And I found the beer and I shared it. So, yeah.
Problem solver.
Oh, the guards had to learn that we carry beer in. They would ask, well, is there anything we should know about it? That bag you're carrying, and the bag was torn. You see Michelob, I'm like, nope, nothing you need to know. It's beer. It's beer. It's beer. You call my boss later on. So, yeah, when you live in the plant, they don't care if you, bring your home and amenities with you. I was known for 11 days without leaving the plant, and I had a air mattress in my office that I would sleep in, and sometimes hot bunk. Like about 2 a.m, I'd figure out what a problem was. I'd get a technician who'd be asleep in my office, wake her up. She would do the wiring. I'd take a nap, and then she'd wake me up about 4:35, and I'd get up, and we fixed every problem got fixed by the next day. We did not have any problems that lasted into the next day, because then we'd start getting behind. We had 5 problems a day, during the 5 months we did the 128. We had 5 custom chips. They're breaking left and right. And so we worked 20-hour days and then spent the other 4 in the bar.
Sounds stressful.
So when I leave Commodore, guess where I end up going to work?
So Bill's actually like 34 years old.
Yes, yeah.
It's all the Commodore stress.
So yeah, I'm walking around the streets, going, you got any stress, man? Anything at all that I can use? So I ended up working at a Cooper Trauma Center, Level 1 Trauma Center in Camden, New Jersey. Became captain of a rescue squad, all just to get my stress fixed, because I got addicted to it from Commodore. So it's a real thing.
Wow.
Yeah. They're like, yeah, I'd go out, shout at cars and stuff, They had to do something with me. Okay, let's get them in a trauma center or something. Unloading helicopters, which I did in the service, so I was old hand. So what do you guys think is cool for the assembly? What's the newest piece of tech for you guys? We were talking paste and pen earlier and stuff like that. What floats your guys' boat in the assembly world? Is there a new insertion machine or a new technique or anything?
So this is kind of old right now. I'd say old.
We're gonna say the same thing.
It's about a decade old now, I think. But there's a. It's mainly because there's not a lot of these machines in the States yet. But there's a company called Micronic that builds a paste jetter. And so this is not a paste depositor. though, like
Yeah.
with a syringe. No, it uses like a piezoelectric head to
sputter it.
sputter the paste in the right spots.
Right.
So you don't have to use a stencil. But the great thing is now you can do like a step stencil and not worry about any of the DFM problems of a step stencil. Or like we were talking about paste and pad before the podcast, you can just like over the hole for the paste and pad, you can just have it keep injecting more into it. Yeah, it's an amazing machine when they work.
I was so up until they stop working, are they consistent, or do they go downhill before they?
No, they're really consistent. What really happens is moisture can get in the airlines.
Right.
Fortunately we fixed that we like revamped our whole air system and fixed all that problems.
So did we at the Penn scale I was telling you about. Yeah.
Yeah. Basically moisture kills pneumatics, and at our old facility we just didn't have really good moisture control for it.
Right. Right.
But yeah, that's like that machine is I'm always like when I go and run that machine, I'm always shocked at how well it puts paste. Like sometimes it can put paste down better than a stencil.
Now, do you use the customer's paste pattern directly, or do you go in and modify them then for your process? Do you do a shrink on the pads, or look for bridges, or what?
Yeah, we typically do a 1-to-1, and then if it's a bigger pad over, I can't remember the number, but there's like a ratio. If it's over a certain number, we will like cross hatch it to make it smaller. Window it. Or if it's like an under package part, like we like the customer to provide it as like a 1-to-1, and then we can modify it to suit the process, because it changes if it's like if we're going to paste jet it or we're going to stencil it. It changes.
Right.
Well, and one of the things about it that makes it feel almost like cheating is that you can paste the board and inspect it, and if you don't like, say, one pad, you can go to that pad, adjust one pad, and then send it. Yeah.
Send it back in.
It's amazing.
Wow.
Yeah, I'll have to get I have to get a new video because it's been a while since I've videoed them, but there's not a lot of them in the States, and it's always surprising that we don't see them a lot here, because like prototype PCB assembly is kind of like, and the low volume stuff too is kind of like where America's manufacturing niche is for that kind of stuff. And it's like, why are we still buying stencils? But especially when you can just go in and again tweak and like, you can put a ginormous like connector right by the BGA now, because you can just adjust the volume of solder on the fly.
Okay.
So it kind of throws out the whole like DFM problems with stencils. Is you just don't worry about them anymore.
So as a customer, I'd like part of that, which is you're adapting to the realities of assembly. But where I wouldn't like it is then I'm dependent on you to do that reliably and consistently from run to run, because I can't do it in the front end.
Correct.
Right?
Yeah.
And that's my thing that I'm wondering about. Like we talk paste and pad, can I get that into my Altium library so that the Gerber is still the source of all of that is holy?
Yeah, and that's one thing I've been thinking about a lot on like how do we. That's one thing in Macrofab I've been thinking about a lot of is like how do you take what, because all manufacturers and CMs change the design in some way and form to make it easier to make.
And it's my job to catch them.
Yeah,
yes.
Yeah. But so it's like, how does Macrofab do a better job at letting the customer know, hey, we tweaked this one thing, you should incorporate it back into your design. Because that's one thing actually like EDA tools don't have is like the paste volume. Like that's just not a thing they do. Like the actual aperture opening, sure, you can draw that in, but the thickness of the stencil, besides just saying it's a 4 mil or 5 mil or that's on an assembly drawing. That's not even just about the part. So that's something that
on someone reading it.
Yeah, someone has to read that regardless. It's not something it's inherent to the part itself, which is something that EDA tools also have to get better at. Is like, can you actually define the 3D space for that pad?
Don't tell Altium that, or they'll make their product harder to use. They already, I mean, I've got great stack up capabilities in Altium, right?
But now you have to do
Right
paste stack
until
up.
it breaks, and I have to read out the whole database, bring in an artificial data, and then redo my stack up. You know, it's just they were so close to, you know.
Yeah.
But it's so complicated that you find bugs, unfortunately.
Yeah, it's kind of hard to think about, like, because also, like, if you were doing PasteJet, you kind of have, like, I don't think there's a competitor to that machine yet. And so it's like, well, then you're stuck with that one vendor or that one CM that's using it that way. But you could, if you're doing a step stencil, then yeah, that fixes that problem. But that has its own host of manufacturing problems.
Do you have to worry about blowing off the VOCs in the paste? Do you have to use a different kind of paste? Well, probably different consistency, but a different mixture in your paste when using the printer?
It actually has its own blend. It's not from, you can get it from the company, but they have a couple third parties that will provide it. And
Right.
it's a different kind of, I mean, it's still a no clean flux.
All right.
But it's weird because when it reflows, it has some like special capabilities in it where like it has like low VOC or something, but it makes like a hard shell on it. It's almost like old rosin where like the rosin would make like a little spot on top and like float on top of it. But rosin would be sticky still. This hardens up to like a caramel coating almost on larger pads. I'll have to take some photos for people to, but it's also one of those things where like if you don't know about that and you try to probe it with your multimeter, you won't poke through the caramel shell.
Chip it.
Yeah, you have to kind of like chip the flux off of it, and then you can probe the pad. It's weird. Yeah.
And it does it look grapey or anything when it does that, or just it looks like reflowed solder?
It looks like reflowed solder. Yeah.
Wow.
It is kind of weird though. They've come out with a water-based flux for that machine. I kind of want to try that out. But the no clean works so well that.
Yeah. So that's why I was going to ask you: is your process is now a no clean based process?
We actually do no clean for SMT, and then we do water soluble for water soluble for through hole. And then and I think, I guess don't quote me on this because I don't know the specifics, but I'm pretty sure it's SAC 305 for sure on the SMT, and I think through hole is SN99, so it's like 100% tin.
Right.
Because I think that's is in that selective solder.
How do you do your? Oh, you just answered my question. You use selective solder for your through hole.
Yeah.
All right. Yeah, I'm from the days of drag solder machines and fountain.
Yeah.
What was it? Not fountain solder. Wave solder. Wave solder. Thank you.
Yeah. Well, if you're gonna be doing a million boards, you don't want to have a chocolate fountain computer go driving around, right?
How long does it take to clean that? That looks like something that probably takes an hour to turn on in the morning. The selective solder machine.
It's actually just like a wave. It's just it's the same thing. It makes it actually makes a little standing wave that's driving around. So it's actually pretty much the same thing.
Wow, those things are cool.
Yeah. Basically the advantage of the selective is you don't need a wave palette. That's what you get out of it.
What's a wave palette? I have a feeling I use a shield.
Yeah. So if you have SMT components on the bottom side,
right,
your wave solder doesn't rip them off.
Right. So what's the shield made of? That's actually not something I've had to work with before.
Durostone, right?
I think that's the trademark name. It's called Durostone. It's like a FR4 derivative. It's like a more
really
denser.
Is it like a tape or like a piece of plastic in form?
Oh,
it's milled plastic basically.
Yeah. Yeah, it's a composite.
Yeah. Okay. Yeah, back in the day, we had to worry about hitting the wave solder in which direction, because you guys know that there's reliability and stuff. And there's times where throw caution to the wind and make it fit. The
Just go
connector.
for it.
Yeah. Yeah. So yeah, do you think I got like a penny per computer? No.
You got an attaboy per computer, right?
They treated us well. They made the guards not bust us for our beer, so we were well treated. It was they knew what created the ability to stay there for so many hours was not needing to go to the bar.
Oh, there you go. Well, do we have anything else that we want to talk about, or should we wrap this up because we're 4 minutes over time?
Yeah. So no, you've hit the points. Again, I'm a big fan of VCF. I think they're doing wonderful stuff, and I recommend everybody check out vcfed.org and check their schedule there. They're all over. I'm just going to the Southwest and West, but there's a Southeast, a Midwest are also happening this summer.
And then, where can people find out more about you, Bill? If
Google.
someone here
Google
that's listening
Bill
doesn't know
with
about
one
you.
L. Yeah, Google Bill with one L, which is how I spell my name, Hurd, and there's no other Bill Hurds with one L, so you'll see I'm in like Wikipedia and stuff like that. So it'll take you to like c128.com. There's a herdware.com website. Oh, I'll tell you one quick last story. On the Easter egg of the C128, if you don't look closely, it says software and then 3 guys, and then it says herdware and 3 guys, and then link arms don't make them, but they invented the word herdware, which would only work with my last name, so for hardware. Yeah. So very cool. Hey guys, this is great though. I appreciate you all taking the time to talk with me like this, and I love talking to the other side of the assembly house, right? Because we're used to pitching stuff over the wall, and we just hope it makes a nice sound when it lands, right? And we know you're over there doing things to make it sound good when it lands. But I like knowing what those are that you do, because again, I like to fix them in the front end if I can. With regard to paste or something. So.
Yeah. Maybe in the future we have a discussion more about that side, and we could maybe do it on your show.
Yeah.
If I'm not just inviting myself, I guess.
That's a great idea. Hey, would you like to come on Coriolis Effect?
I would love to, Bill.
Okay, that'd be cool. I believe you know Ben Jordan, our co-host.
Yeah.
Yep, Ben's been on the podcast.
Yeah.
Yeah.
Well, cool. I'm going to
thank you
thank
so
you one
much
more
for-
time, Bill, because it's been a blast.
Yeah, I had fun. So, all right, guys. Take care.
Don't leave just yet, Bill.
I'm not.
Okay, cool. So that was the MacFab Engineering Podcast. We're your hosts, Parker Dolman.
And Stephen Craig.
Later, everyone.
Take it easy.
Bye.
Thank you, yes, you, our listener, for downloading our podcast. If you have a cool idea, project, or topic, let Steve and I know. Tweet us at MacFab, at Longhorn Engineer, or at AnalogENG, or email us at podcast@macfab.com. Also, check out our Slack channel. You can find it at macfab.com/Slack. Okay, now everything's uploading. Looks like
Cool.
everyone's almost done already, which is great.
How many people watched? Did you?
So we had,
It looks like 2.
2 currently, and it looks like at 1.8. We usually don't get a lot of people watching the live stream.
Right.
But we get about 5,000 downloads a week.
Right. Now, we don't do the podcast format. We do have a dozen people that watch us live. Sometimes it gets up to 80 or 90, though, which is not a bad live thing. But our whole thing is I hate post-production. So we produce an inferior product so that I don't have to do post-production.
Yeah, I just pass it off to the editor.
Ben and I need one. We do. Ben especially. He's burning the candle at both ends right now. So excellent. All right. So my audio uploaded. Yes, it says your recording was fully uploaded. So we're good here.
I think you're good to go.
All right.
All
Yeah,
right.
thank you so much, Bill.
Would
you,
you
Bill.
want to be on our thing together, or just Parker? You only invited yourself, so I didn't hear you invite Steve there.
If Steven wants to come too, that's totally cool. I don't
Yeah,
mind.
I mean,
It's
that,
up to
that
you.
would, that would be super fun. Yeah.
Yeah. All right. Yeah. Let me pass that back to Ben and see where we go with that.
Okay, cool.
So now with that said, it is live, so we need to. It's Fridays at 11 Pacific, which is 2
1
Eastern.
Central.
Yes.
That's okay
One-
with me, by the way.
Okay.
Though
Okay.
it's gonna be like that's after. So Steve and I play games on Friday nights. We're gonna be like drunk.
No, it's 1 in the
No,
afternoon.
during the day, not at
during
night.
the day.
Yes.
Or we can
That's
still be
why I
drunk.
meant- We yeah. Better not be drunk.
Yeah.
Better not be running my boards if you're drunk. So Judy Warner tells the story about she was working in a PCB fab house in California in the 70s, and the guy blows a big number, right, that's running one of the machines. And so he's just hired shit. And he cut the fingers off of the printed circuit boards. He ran it through the machine and it milled off the fingers, the gold fingers.
Yeah.
Of like 100 boards or so. And it's like she's trying to, how is she going to explain that there's a couple week delay because gold fingers back then were hard, that the guy was really high. And you can't say, well, it's California, so it's so all right, guys. Hey, you all have a good evening.
Thank you,
Hey,
Bill.
thank you, Bill.
All right, later.
Steven, hang around.